So our next presenter is Dr. Lorenz Fischer. He is with PreSens, and the presentation, Online Measurements of Metabolic Activity, Accelerating Your Bioprocess Development. So with that, I will introduce Lorenz.
Welcome, everybody. Thanks for the introduction. Thanks for stopping by. My name is Lorenz. I'm from a company called PreSens. We're a manufacturer of optical chemical sensors, and we're specialized in online monitoring of the parameters pH, oxygen, biomass, and carbon dioxide. Today I'd like to give you a short rundown on our company and on the products that we're showing, especially on this show. The product that we're focusing on in this show is a device for measuring online oxygen and pH and biomass in a shake flask to accelerate your bioprocess development by online measuring your metabolic activity in your shake flask. So, like I said, I'd like to start with a brief rundown about our company. PreSens is based in the south of Germany. It was established in 1997. The University of Regensburg has a very renowned chair of analytical chemistry, and PreSens is a spin-off from that chair. PreSens is privately owned, and like I said before, we're specialized in monitoring essential parameters. Currently, we're close to 100 employees, and we are certified to various quality standards. Here on the picture, on the bottom of the page, you can see the ancient town of Regensburg. If you're anywhere close to Regensburg, I can recommend stopping by. It's a very pretty city. Stop by at PreSens. Yeah, you'll be welcome. I'd like to continue with a brief rundown on our sensor portfolio. So we have sensors for oxygen, pH, carbon dioxide, and biomass. The key feature of our technology is that it's a non-invasive technology, so you can measure through the wall of your vessel. It's all optical. These are all optical sensors, so there's no physical contact between the actual sensor probe and the transmitter. Only the sensor probe, which is a fluorescent membrane, has to be in contact with the media or the solution that you want to measure. The format of the sensors can be what we call mini sensors, that would be a range from 2 millimeters up to a few centimeters, or micro probes that go down to a size of 20 micron. The basic principle of these optical sensors is a small patch of fluorescent membrane that is integrated into your vessel. It is glued to the wall of your vessel, on the inside of your vessel, and is read out from the outside through the wall. So all you need is optical contact to your probe. You only need to be able to shine light through the wall of your vessel. So it will not work in a black vessel or in a stainless steel vessel, but for all disposables, plastics, glass, it will work. The disposable or the wall can even be amber colored, or it can be turbid, doesn't matter. Also, the solutions that you measure, they can be colored. They even can have background fluorescence. Our probes are optically insulated against those influences. The benefits of an optical measurement is that it is a non-invasive measurement. You don't have to interrupt your process to draw a sample from your flask or from your vessel. It's sampling free, and that means it gives you a real-time monitoring of the parameters. You can integrate the sensors in any vessel, so it's a very versatile technology. It's very flexible and easy to use. And if you're using it at very small volumes, it might be interesting to mention that oxygen is not consumed during the detection. And also, all the sensors that we manufacture are tested for leachables and extractables, so they are not toxic and they're FDA approved or USP Class 6 approved. Here are just a few examples of applications. We manufacture shake flasks with integrated sensors. Our sensors are used in testing of oxygen ingress into PET bottles. They are used in all other sorts of disposables or for monitoring in bioreactors. Our customers are can mainly be divided into 4 groups. Biotech and pharma. We have a lot of customers from food and beverage as well. Customers from scientific and R&D, and we're also a supplier for medical devices. Here on this show, we would like to specifically focus on the measurement in shake flasks. We have a new product, the so-called Shake Flask Reader Vario, which we present on our booth. Why shake flasks? Shake flasks have certain advantages. There are established protocols for microbial cell culture and other types of cell culture, where shake flasks are an established labware to use. Shake flasks are fast and easy to handle. It's an established equipment. They provide less shearing stress compared to stirred systems. And you have KLA values that are above those of microtiter plates, tubes, or cultivation bags. So far, a shake flask without its sensors has certain disadvantages as well, because it has a high ease of use, but you gain only little knowledge if there are no sensors inside the shake flask. Compared to a bioreactor with integrated electrodes, with integrated electrochemical probes for pH and oxygen, you only gain very little knowledge from a culture in a shake flask. With our device, the Shake Flask Reader Vario, this is completely changed, because by integrating pH and oxygen sensors into your shake flask, you also gain a lot of knowledge from your culture directly out of your shake flask without drawing samples and without having to modify your existing equipment. Because our device, the Shake Flask Reader Vario, will fit in any commercially available shaker. A standard width shaker will fit up to 4 devices. The device comes with a purpose-built software where you control up to 4 devices at a time, and it will easily help you evaluate your data. How does it work? We use standard shake flasks. We integrate 2 sensor spots in them, one for pH, one for oxygen. Here you can see the bottom of a shake flask. In the back there, those are the 2 sensor spots. The other 2 dots on the bottom of the flask are only 2 aligners that make sure you can't misplace the flask. So it makes sure that the sensor spots are always on top of the optics. It's a fluorescent technology, so the way it works is you shine excitation light, a pulse of excitation light, onto the sensor spot, and the sensor spot will react by emitting fluorescent light. This fluorescence is dependent on the concentration of the analyte. So a change in pH or a change in the oxygen concentration will change either the fluorescence intensity or the fluorescence lifetime. And that's actually what we're detecting. This is a photograph of an actual reading. A reading itself will take about 200 milliseconds. So you can sample the readings down to 1 reading per second, pH, oxygen, and biomass. How does the biomass measurement work? It's a optical density measurement, so it's actually a light scattering measurement at 560 nanometers. And if you imagine a running shaker, of course the fluid height in the shake flask varies all the time. And if you want to have an accurate biomass measurement, you need to make sure that the fluid height is always the same at the moment you do the measurement. So in the Shake Flask Reader Vario, there is an integrated G-force sensor that makes sure that the biomass measurement is always triggered at the same fluid height. So if you change the shaking speed during the measurement, the G-force sensor will automatically recognize that and trigger the biomass measurement at the same fluid height as like at a different shaking speed. This is a picture to illustrate that. So the G-force sensor will give a certain angle in which the biomass measurement is triggered to make sure you get accurate readings of your biomass. The SFR Vario that I was talking about comes with certain accessories. Like I mentioned, it comes with the software. The software is brand new. It's very easy to handle. It has very convenient data evaluation functionalities. The complete system is absolutely wireless, so data communication is via Bluetooth to your PC. It's battery powered. It comes with 2 batteries, but it will run with 1 battery as well. So if you want to do a measurement that is very long and exceeds the battery lifetime, you can take out 1 battery, recharge it, put it back in, recharge the other battery, and you do never have to stop your measurement. We offer shake flasks, disposable shake flasks with integrated sensors. But for the oxygen sensor, there is an autoclavable version available. So if you want to work with glassware, we also have glass flasks with reusable oxygen sensors. This is what the device looks like. You can take a look at the device at our booth 1964 back there behind the first pillar. Like I mentioned before, the device will fit in any commercially available shaker. You do not have to do any modifications to your existing equipment. And the software it comes with will operate 4 devices, like I mentioned before. Here on the bottom left of the page, you can see the actual optics. They consist of a light source and a detector for each parameter. And for the biomass measurement as well, you have a 560 nanometer light source and the scattered light detector. Now I'd like to show a few examples of applications of the Shake Flask Reader Vario. So this is an experiment where we used where a 1 liter shake flask was used, and it was used with various volumes. And what you can see here is the dissolved oxygen concentration in the shake flask at various filling volumes at a constant shaking speed. And you can see that in a 1000 milliliter shake flask at 500 milliliters filling volume, the dissolved oxygen concentration is down after about 40 hours of cultivation time due to the low aeration in the high filling volume. So this shows you clearly that at lower filling volumes you have way better aeration, and you can see this with our system without having to draw a sample. The spikes that you see in the measurement curves are actually reference measurements that were done by drawing samples, and you can see in these spikes that this drawing of the samples has a severe impact on the values in your shake flask. Another simple example, this was a choke cultivation where they monitored the pH value with our Shake Flask Reader Vario. And this was done at a university in Germany, at the University of Bielefeld. And what you can see here is the decrease of the pH value during the choke cultivation. And you can see those parts of the curve that are pretty linear. And then there are those really noisy parts with a lot of spikes. And this was an incubator that was used by various guys who did their PhD at that time in that lab. And it's day and night. So the parts with the spikes are the days where all the other guys opened the incubator. And you can see that this has already a severe impact on your pH value because you lose all the CO2 atmosphere. So what our system would enable is that you could do an online measurement of pH, O2 and biomass where you do not have to open your incubator and you do not have to draw a sample, and you could foreclose those spiky curves and you can foreclose those impacts on your culture. Another choke cultivation example done by Roche. Here they used our system to keep the dissolved oxygen concentration and the pH value in a certain range. So they monitored dissolved oxygen and pH with our system, and they tried to control it by adjusting the shaking speed or the CO2 concentration. So the upper graph shows the oxygen concentration in the culture and how they controlled it by adjusting the shaking speed. So at higher shaking speeds, of course, you get better aeration and higher oxygen concentration in your culture. And in the lower graph, you can see the pH value and how they controlled the pH value by adjusting the partial pressure of carbon dioxide in the incubator. And they did this monitoring without drawing any samples at any time. This graph is looks a little more complex at first sight, but it's actually pretty easy. You got the blue curve, that is the biomass measurement done with our instrument. And they drew samples. Those are the spikes that you can see in the red curve. The red curve is the oxygen concentration, the DO concentration. And they also simultaneously monitored pH in their culture. And what you can see here is a deoxic metabolism of E. coli. There was glucose monohydrate in the media and lactose monohydrate. And at first, the E. coli digest the glucose. And after all glucose is digested, you can see a change in the curve, in the biomass curve, where the increase in biomass changes because they change the metabolism from glucose to lactose. Again, the spikes in the DO curve are from drawing the samples. Here again you can see the impact of having to draw a sample on the DO concentration in your culture. This was just for reference purposes, so they were just validating our system, but with our system you do not have to draw any samples to get the DO reading. Another example for a yeast culture. Here, colors of the curves are the same like in the graph before. You can see that after all glucose is digested by the yeast, the more or less exponential growth in biomass is put to a stop and is then carrying on in a linear way. And the O values are going down according to the biomass going up. And then the biomass increase carries on for another little more than 10 hours in a linear fashion. And it comes then to a full stop. And the dissolved oxygen concentration goes back up again because cell growth has stopped because there's nothing more to digest. So in summary, here on this show we're focusing on our new instrument, the Shake Flask Reader Vario. It's an instrument fitting in any commercial available shaker. You do not have to do any modifications to your existing equipment. You can measure dissolved oxygen, pH, and biomass online in your shake flask. You measure through the wall of your shake flask. You do not have to open it. You do not even have to open your incubator because it has wireless Bluetooth communication to our software. It's a real-time measurement with the oxygen values that you're getting from those measurements. The software can do an automatic oxygen uptake rate calculation as well. You can measure up to 4 devices in parallel. And like I said, it's completely wireless, it's battery powered, and it's definitely a very efficient tool to speed up your bioprocess development or your media optimization. If you're interested to take a look at the instrument, you can see it live at booth 1964 back there between the halls, back between the first pillar there. Thank you very much. Do you have some questions? No, it's only visible light.